Alright, this is 5.6 B as in boy, and we're continuing on with our cofactors and minors. And let me, again, just go over this. The minor is what we did first. The cofactor is just the minor with the right sign on it, depending on where it is in the matrix, depending on its row and column. Alright, so we did one part in the last video. We did a 1-1 where we did this, found the minor of that, and then found the cofactor. We're going to do the same thing, only instead of 1-1, we're going to do 2-3. So the easiest thing is to go like this, get rid of row 2, column 3, so you can go from there. And that's what we'll do here. Alright, so for the first thing we're going to do is we're going to look at that 2 and 3. We're going to add those together. We get an odd number. So I know that whatever answer I get for my minor, I'm going to change the sign, and that then will be the cofactor. Alright, so let's go ahead and do that. So that's all I need to know is I'm going to change the sign because 2 plus 3 is an odd number. Okay, so basically I can just do this to tell me that eventually I'm going to switch the sign. Whatever answer I get from my minor, which is going to go right here, I'm going to multiply it by -1, which means it's going to switch the sign. Alright, so let's go ahead and find the minor. I have, again, straight line, -8, 0, 1, -3. So -8 times -3 is 24, minus 0 times 1 is 0, gives me a 24. This negative here tells me I'm going to change the sign, and that then becomes my cofactor. Okay, that's it. That's all there is to it. So what have I shown you so far? I've shown you how to find a minor, which is what we did right here, of any of these elements. In this one we found the minor of the position of 2, 3. And then I told you how to find the cofactor. You just take the place value here, row 2, column 3, add those two up, get a 5, and then whatever answer you get, you change the sign because it's an odd number when you add 2 and 3 together. And that gave you your cofactor. So your minor was 24. Your cofactor is -24. And again, the only reason, or right now, as far as the difference between the minor and the cofactor, is the minor tells you, based on these numbers, what you're going to get when you multiply this and subtract that. The cofactor says because that number is in this position, it's going to be negative. Okay, that's all this negative does, is it tells you what position this is at, and depending on the position, depends on whether that minor is what it says it is or whether it's going to be the opposite. Okay, so knowing those two bits of information, let's go on to a third part. Now this third part, we need to know how to find the minor. We need to know how to find the cofactor, and that's why we did those two first in order to do the determinants. And that's what we're going to do now, is we have not done determinants yet. We did on a 2x2, the very first thing we did a determinant. In fact, we used determinants because we made this into a 2x2, right? This minus this. Okay, so we did a determinant for a 2x2. Now we're going to work at finding determinants of any square matrix. So if we have a 12x12, we can find the determinant. Okay, so that's this next part. And you had to know minors and cofactors in order to get to this next part. Alright, so here's how you find a determinant of any matrix. You multiply each element of the first column by its cofactor. See, there's that word cofactor, so you have to be able to find the cofactor, and then adding. Okay, and what we're going to do is we're going to, when we're talking about a determinant, we're going to do this. That says I want to find the determinant of A. Okay? Now, the way we do this is we take the first element. So let's go back to our 8, 4, 1, 0, 6, negative 6, 7. This is one we've been working with. Okay, so there's our matrix. All right, so we find the determinant of this matrix by multiplying each element in the first column by its cofactor and then adding. So negative 8 times its cofactor plus 4 times its cofactor plus 1 times its cofactor. Okay, so that's what we're going to do to find the determinant. All right, so first of all, we're going to remind ourselves how to find the cofactor of each one of these numbers. Then we're just going to take negative 8 times that, add it to that times that, add it to that times that, and we found our determinant. Okay? Now, when I explained this, I said the first column. So we look at all three numbers in the first column. It doesn't have to be the first column. It could be the second column. It could be the third column. It could even be the rows. So what I choose to do is I look at the columns or rows that are going to be the easiest. Like I would probably choose row 1 maybe because this has a 0. So I know that this middle one right here would be 0. So that just saves me some work. But it doesn't matter. You're going to get the same answer whether you take these 3 rows and do each of those or you do each of the columns. You're going to get the same answer. Okay? So let's look at example 4. And example 4 is the one we have been working on. But what it's saying here is they're asking us to find the determinant based on the third row. This one right here. Okay? Now it doesn't matter which row you do or which column, but they're just being specific just to show you one particular way of doing this. Okay, so let's kind of write out what we're going to do here. So we're going to take each element, negative 1, negative 3, and 5. We're going to multiply each one by their cofactor, and then we're going to add them together. So negative 1 times the cofactor plus negative 3 times the cofactor plus 5 times the cofactor. Okay, so now what we need to do is we need to find the cofactors of each one of these, multiply them by the numbers that we have here, and then add them together. And that's really all there is to that. All right, so to find the cofactor of this negative 1 right here. Okay, so what we have to do is find out what position this negative 1 is in. It's in row 3, column 1. So that is in row 3, column 1. Okay, and when we add those, we get a positive number, or we get an even number, so that means this doesn't matter. Okay, it is not going to make our minor change its sign. So if you get an even number, just realize nothing's going to change. Okay, so this negative 1 is still here because it's part of that. It's the element. All right, so now we have our minor. What is our minor? Our minor is going like this and like this. So we have 0, negative 6, 6, and 7. 0, negative 6, 6, and 7. Okay, so we still have that minor there. Okay, let's keep going here. We have our negative 3. And what position is negative 3 in? Row 3, column 2. 3 plus 2 gives me a odd number. So that means this answer here is going to change its sign. No matter what we get for an answer, we're going to change its sign. So what you can do, you can change the sign later, or I can just change the sign of this negative 3 to a positive 3. Okay, and so basically I've changed the sign. All right, so what am I going to get for my minor? I am going to get a negative 8, a 6, a 4, and a 7. Okay? And then I've got a 5. And what position is that 5 in? It's in row 3, column 3. 3 plus 3 is 6, gives me an even number. This is not going to have a sign change at all, so I leave that the way it is. And I get, for my minor, Okay, so let's look at each one. Let's do that. 0 times 7 is 0 minus a negative 36. And then I have to multiply it by negative 1, like that. And remember that negative 1 came from there. Okay, so now I've got my 3 from there. And I'm just going to put in brackets here. Negative 56 minus 24 plus 5. Again, let's do the minor, put it in just brackets here. 48 minus 0. Alright, so we have negative 1, 0 plus 36. Whoops. It's going to be times plus 3 times negative 80 plus 5 times 48. Okay, so negative 36 minus 240 plus 240. So my answer then is negative 36. So that is the determinant of that. Now if I would have done this row, or this row, this column, or this column, I would have got negative 36 regardless. Doesn't matter which row or column I choose. You know, like I say, I probably would have chose this column or this row, because then I'm not dealing with 3 numbers here. I'm just dealing with 2, because this 0 would cancel out this middle number here, so it just makes it easier. Alright, so that's the only example they give you for this, so hopefully you've kind of caught on. It's done the same no matter how big the matrix is. You just have to do, I mean, this one we did it 3 times, but if it was a bigger matrix, you'd have to do it 4 times or 5 times or 6 times. Alright, so this next section that we're going to do, and I'm going to start a new video for this, is called Cramer's Rule, and I think you'll like this one.